Hello everybody. Today we are going to discuss the dual nature of radiation and matter. This whole discussion starts from the cathode rays that is discovered by the Williams Crookes. Cathode rays, the stream of fast moving electrons, it can be produced with the help of discharge tube with very low pressure 0.001 mm of mercury. Some specific properties of the cathode rays. Cathode rays not the electromagnetic waves. Cathode ray may be deflected by the electric field and magnetic field. Cathode ray can produce heat in the metal. Cathode rays can pass through the aluminum and gold foil without punching them. Cathode ray can produce the physical and chemical change. Cathode rays can travel the straight line and produce momentum. On striking of the heavy metals, it can produce X-rays. Cathode rays produce the fluorescence and phosphorescence in certain substances. When in charged particle moving in the field, in magnetic and electric field are present in balanced manner, it cannot be deviated. So through this, you can calculate the velocity. The specific charge of the cathode rays means the ratio of charge and mass. The specific charge first determined by the J.J. Thomson using the setup in which the electric and magnetic field applied perpendicularly on the beam. The value of a specific charge of electron is approximately 1.7589 to 10 to the power 11 coulomb per kg. Millikan established the electric charge is quantized and through his popular oil drop experiment determined the charge value, specific charge and mass of the electron. The charge on electron is determined by the Millikan is approximately 1.602 into 10 to the power minus 19 coulomb. Why free electron cannot escape out from metal surface? Metals have free electrons that can be responsible for their conductivity. However, the free electron cannot normally escape out from the metal surface. If electron attempt to come out from the metal surface by taking the energy from some external source, the metal surface acquire positive charge and pulls electron back to the metal. But after gaining the sufficient energy, that incident light or some other way, the electron can escape from the metal surface of into the surrounding. The minimum energy required by the electron to escape from the metal surface is called work function. It is generally denoted by phi naught in electron volt. 1 electron volt is equal to the energy acquired by the electron when it is accelerated by 1 volt and is equal to 1.602 into 10 to the minus 19 joule. Electron emission can be done by the different process. The first process is thermionic emissions, in which metal surface are heated at a certain temperature after the electron are free to evacuate from the metal surface. Example is electron gun. Photoelectric emission, photoelectric effect is observed in which at particular frequency the electrons are out from the metal surface. Field emission, in this very high field is applied across the metal plates and spark is creating and through the electrons are out. As per the Einstein discussion of photoelectric effect, light is not the continuous one, it is discrete, it is a form of packet. Those packets are called photons. The photons packets as energy emitted by the source of radiation. That energy is defined as E equal to h mu, where h is the Planck constant, mu is the frequency of the radiation. Rest mass of photon is 0. But you can calculate the dynamic mass of the photon. That will be equal to the h mu divided by c square or h upon c lambda, where c is the velocity of light, lambda is the wavelength. A body can radiate or absorb energy in whose numbers are multiple of the quantum, that is h mu, 2h mu, 3h mu and so on, where n is the positive integer. Photoelectric effect. The emission of electron from the metal surface when the radiation of suitable frequency is incident on it called photoelectric effect. The work function, the most important parameter of this phenomena. The minimum amount of energy required to eject one electron from the metal surface is called work function. Threshold frequency, the minimum frequency of light which can eject a photoelectron from the metal surface is called threshold frequency of the metal. Threshold wavelength, the maximum wavelength of the light which can eject the photoelectron from the metal surface is called the threshold wavelength of the metal. they have a relationship phi equal to h mu naught or hc upon lambda max. Law of photoelectric effect. First, for given metal and frequency of incident light, the photoelectric effect is directly proportional to the intensity of light. You can see in the graph when the intensity is increasing, photocurrent is increasing. For a given metal, there is a certain minimum frequency called threshold frequency below which there is no emission of photoelectron take place. Above the threshold frequency, the maximum kinetic energy of the photoelectrons depend on the frequency of incident light. Photo emission is the instantaneous process. As per the Einstein photoelectric equations, the maximum kinetic energy of photoelectron can be defined as the h mu minus phi, where the mu is the frequency of incident light, mu naught is the threshold frequency. Stopping potential. The minimum negative potential given to anode plate at which the photocurrent becomes zero is called stopping potential. The maximum kinetic energy of photoelectrons is equal to the half mv square Vmax is equal to E V naught. V naught is the stopping potential here. Matter's wave on de Broglie wavelengths. Very bold hypothesis given by the de Broglie. As per this, a wave is associated with every moving particle called the matter or de Broglie wavelength. De Broglie wavelength. If the particle of mass m is moving with a velocity v, then the wavelength of de Broglie waves associated with it given by lambda upon h p or h upon mv, where you can further modify this formula with the value of kinetic energy, and that formula is h upon 2 mev raised to power half or 1.227 divided by under root v in nanometers. Da Vinci experiment established the de Broglie relations. This experiment verified the wave nature of electron using the nickel crystal. Da Vinci and Garman found that the intensity of scattering beam of electron was not same for the different angles of scattering. Its maximum diffraction angle is 50 degree and 54 volt potential difference. It established that the wave packet description together with the de Broglie relation, Bohr's probability interpretation reproduce the Heisenberg's uncertainty principle exactly.